Hello Internet, my name is Quinn and this is Blondihacks. This is Lathe Skills number 4, tail support. This is a series of quick videos on getting started in machining. If you like this content, please subscribe on Patreon where I regularly post exclusive project videos. Okay, let's dive in. The purpose of tail support is to increase rigidity in the machining setup. I'm going to demonstrate that on this piece of drill rod here. So notice that unsupported, very light pressure, I can move this a lot. And you can see how any kind of cutting pressure on that would cause the part to simply move and cutting would be ineffective. Now watch what happens with a little bit of support on the end. All of a sudden, this gets really quite rigid. Now this same effect is present at a much smaller scale in any part that you machine. So whenever you have a lot of stick out from your chuck, you always want to be using tail support. So how much stick out is too much? Well, it varies by how aggressive your cut is and what your material is, but a general rule of thumb is you don't ever want to be sticking out more than 2 to 3 times the diameter of your material. So if this is 1-inch diameter material, I don't want to be sticking out any more than maybe 2-3 inches. And less if it's aluminum, you can get away with a little more. If it's steel, you can get away with a little more if you're taking light cuts, but in general, 2 to 3 times you stick out, you should be looking at tail support. How does tail support actually work? Well, down here on the other end of the lathe, we've got the tail stock, and it's got a tapered bore in it, and that bore will accept different types of centers. So here we've got a dead center, which is literally just a piece of tool steel that's shaped in a taper with a point on the end. Or here we've got a ball bearing live center, which has a tip on it that spins. And there's different use cases for each of these, but they both install the same way. The taper, this is a Morse taper 2, fits in there like that, and just jam that guy in there. And the pressure of the work against that will seal the taper against the sides, and it'll hold it in place. And then when it's time to remove it, it's going to be pretty wedged in there, so you crank the tail stock all the way back, and there's a little plunger in there that'll just pop that guy right out. All right, now let's prepare our work to accept these centers. To prepare the work for tail support, we start by facing it off. You can watch my video on that. And the next step is to center drill it. And center drilling is done with center drills. Now these guys come in a number of sizes. This is a pretty typical set from number 1 through number 5. And number 2 is a good generally useful size. Center drills are different than regular drill bits that you might be familiar with in that they drill right on their point, which regular drill bits do not. So regular drill bits, you've seen that they wander all over the place. That's because they don't actually drill right in the center. So center drills do, and center drills are also very short and very rigid. So when you line them up with something and you start drilling, they won't wander around. They'll drill right where you put them. And center drills are also double-ended because they are short and rigid. They tend to snap so that when you inevitably break one, you can use the other end to pick the shards out of your teeth. All right, let's center drill this to get it ready for tail support. Center drilling is done at quite a high speed because remember at the center of that work, the surface speed is close to 0. So you want to make sure you have enough surface speed there for the cutting action of the center drill to do its work. Now a little bit of cutting oil is always a good idea on center drills. And then we're going to lock the tail stock. And then we're just going to ease the center drill in. We're going to kind of touch it off a little bit, let it find its center. And then we're just going to start easing that into the work. You generally want to go about 2/3 of the way up the tapered portion of the center drill. If you go too deep, it's going to break off. If you don't go deep enough, then it isn't going to provide sufficient support. So brush the chips off so we can see what we're doing. And then we'll go a little deeper. And right about there. So I want to bring you in close so you can see how the physics of tail support actually works. The center drill has created this small tapered surface here, and this tapered surface is what's actually doing the support. Well, you can see how when this center goes in there, it's going to fit perfectly right in there like that, and that's because the angle of the center drill is the same as the angle on all centers. Those are standardized. So when this guy is in here, those tapered surfaces on the work are nestled perfectly against the tapered surfaces of the center, and that's what's providing that up and down support and giving you that rigidity. Okay, with my work set up in the chuck with the right amount of stick out for my next operation, I can now set up my center. This is a dead center, which is an inexpensive option. Dead centers are nice because they don't take up a lot of room, so you can get in here close with the tool post if you need to do tight operations. But of course, dead centers don't spin and the work does, so that means there's going to be friction in here. If there's too much friction, this interface here is going to heat up, and what that will actually do is cause the work to expand, which is going to cause problems for your operation. So we want some kind of lubricant on here to prevent that, and it needs needs to be sticky, so you can use something like a high pressure wheel bearing grease or whey oil, because whey oil is sticky. Just something in there that's going to stay put. So I'm going to put a couple drops of whey oil on there. And then next you want to lock your tailstock in place so that the ram doesn't just push it backwards when you crank it in. And we can start bringing in our ram. And you want to just kind of get moderate pressure on there. Don't put your 200-pound gorilla muscles on it. And just spin this chuck by hand, and you'll get the feel of it when it feels about right. Then just hold that pressure on there and lock that ram in place. And the system is now nice and rigid. Another option is a live center, and the advantage of these guys, of course, is that the center spins. So these are super easy to set up. You just crank that guy in there, tighten down your ram, and Bob's your uncle. Your work is tail supported. The disadvantage to these guys is because there has to be ball bearings in here, they take up a lot more space, so it can be hard to get the tool post in here for close-up work. And of course the other disadvantage to these is that they're kind of expensive because these bearings in here have to be very high precision in order to prevent run out in the end here, which if you had run out in the tailstock, then it would introduce taper or chatter or other negative artifacts into your work. So these are a little spendy, but they are extremely convenient. And that is tail support in a nutshell. We can now do turning operations with confidence, knowing that this is rigidly supported. I hope you found this useful. Please do subscribe on Patreon, where I post exclusive project videos on a regular basis. Thanks for watching, and we'll see you next time.